Hi everyone. Today I'll be going over some of the problems for AI Camp right now that we've worked on. So I'm Sania Kuller, and I'll be going over some of the homework problems right now. So let's get started. Right now, if you go into the coding center, what you should see is the following. So here we have homework on our lists as well. And so we usually start out my name with Sanya, for instance, and you write whatever your name is there. So when we want to assign the fifth element from this list to a variable and print the element in a list, what we see is, for instance, we have this list. We're going to define it as a variable. My list equals all of these elements here. And in a list, what we have is we have the indices. So the first element is index 1, is index 0. Then this is index 1, 2, 3, 4, 5, and 6. So these are the different indices in a list. If we want, and so these are in terms of index. In terms of elements, what we have is this would be 1. So I'm moving over a little bit. Indexes, this would be elements 1, 2, 3, 4, 5, 6, and 7. You see the relationship is that the index always starts at 0, 0, 1, 2, 3, 4, 5, 6. And the elements will always be the index plus 1. So if we need to print the fifth element in the list, that would be here, which would be under index 4. So to access anything in a list, we do my list, bracket 4, and then we would get 8 here, which is what the output should be. The fifth element in this list should be 8. So how would you print the sixth element in the list without assigning it to a variable? So also, if you want to print it, we can just also reprint it like this way, or we can also do print my list 4 and get the same results. We could also say fifth element equals my list 4, and we can then do print fifth element. You see, this is the same that gets printed out first, and this is the same which gets printed out next. So how would you print the sixth element in the list without assigning it to a variable? Please create code that would show that. So what you will do next is you're going to find out what this sixth element is. And that looks like my list. So again, the relationship is if we want to get the sixth element, we will need to go to the fifth index. And the index is what we call in these brackets. So for the fifth element here, we wanted the fourth index. So here, if we want the sixth element, we will want the fifth index. So we want my list, and then we want to have 5. And we can then do print my list 5. This will print out the sixth element in the list. So this is the index 5. So again, the elements is like if we want to count 1, this is the first element, second element, third element, fourth element, fifth element, sixth element. Oh, let me start again. First element, second, third, fourth, fifth, sixth, and seventh elements. So that's what this will be. How would you print out the last element of the list? Will this solution work for any list? If not, please go back and do some research. Okay, so if we want to print out the last element of the list, what we will do is we're going to see here that in my list, we have so the length of my list tells me how many elements there are in my list. So there's 7 elements, all these 7 elements, elements here. If we want the last element in the list, we can also do my list, and then we can take the bracket 6, right? But tomorrow, if we have a longer list, it might have even more elements. Like what if my list has for instance, what if my list has another element? It's we need to make it more flexible. Like what if tomorrow it's 27 and then we have 7 indices and we have 8 elements, then it's no longer going to be the last one. So we're going to need to find a way to make this better, right? So this is like example list. Is this. So it's not always going to work because we're going to have, we can have multiple elements in this list. And it can increase or decrease, so we can have a smaller list and maybe the list ends here, maybe this is the whole list. So, and it's at index 5 for element 6. So what we need is to get the last element of a list, we need -1. Because I can write something here that's called negative index. And what this does is a negative index essentially starts out with -1 from the rightmost. So it goes from the right all the way to the left, so in the opposite direction. So think if you're going on a number line, if you go in the left direction, you go to the negative direction. So this will be -1, this will be -2 below right here, this will be -3, this will be -4, and this will be like -5. So it keeps getting negatives in each direction. So this is like -1, -2, -3, -4, -5. This will be -6. This will be -7. And then this will be like -8. So what we see here is like, for instance, it looks like this kind of. You sort of see that this is the same -8 is because there are 8 elements here. So this will be -8. There's no such thing as -0. So we have to start at -1, -2, -3, -4, -5, -6, -7, and -8. So we always know that no matter what, the first element in a list we can always access with index 0. And the last element in a list we can also access with negative indexes. So example list at 0 is going to be the same thing as example list at so this is 1, at -8 will also be 1. So if I want element like the last element in this list, I could look up the indexes is what you use. So indexes are what we use to access elements from a list. So it's a list bracket index to access a specific element. So example list, if we want the last element, that'll be -1, which is 27 here. Or we can just go to the index 7, and that's also going to be 27. But you see what is safer is that, like, because we went from having like 6 indexes, 7 elements, all the way to having 8. So it's safer to use a negative index, -1. So in general, using this index for the first element in the list and -1 for the last element in the list, it's always going to be a true. So you want to use something like this. So since we're using my list of -1, and again, my list looks like 1, 2, 3, 5, 8, 13, and 21. The last element is 21. So the indexes would give us, that we're going to instead, the negative index would push everything like this in a way. Negative index would mean that we would have, I'll just call it neg index. And this would just have everything as like everything's moved over. So now this is the -1, -2, -3. No matter what, the last element always starts at -1. So now we can just do my list of -1, get our 21, and that will be the last element in this list. So my list is here. So if you want to sum the following numbers in this list, 1, 2, 3, 5, 8, 13, and 21, we want to basically add them up. 1 plus 2 plus 3 plus 5 plus 8 plus 13 plus 21. We want to sum them up to get 53. Because my list, it looks like, so again, my list looks like the following: 1, 2, 3, 5, 8, 13, and 21. So we want to get all these elements. We can write code to do this, basically. What we want to do is we see that we have 1, we have 2, 3, 5, 8, 13, and 21. So we want to add these elements together. So we will need to do my list at 0 is what this 1 is. So let's actually take it apart as follows. So we have my list at 0 instead for this. This is the 0th element. So let me have this on the top, and then at the bottom, I'm going to just keep on replacing each of these. So this is my listed 0. This is my listed 1. And we're going to keep going and having my list at 2, my list at 3, my list at 4, my list at 5, and my list at 6. So what we see here is we go through and we can add this and this and this and this together, and we'll also get 53. So we want to wonder, how can we sum all the numbers in this list? We can do this and this, but what if tomorrow we have another list? What if I have another list that's like of numbers like 9, 29, 0, negative 2, maybe 3, 28. Like, what if I have it? Maybe I have like 100, for instance, 2, 3, 4, 5, 6, 7. And let me just say I have like let's say I have all these numbers. So another list is basically it has like all these elements, and it has the length of this list is the length of another list. The number of elements in another list will be 9. So here it was 1, 2, 3, 4, 5, 6, 7. So I have 2 more things. Then, well, I have to change this and add more to this, right? To do this. And how do I know to do that? How will I know it? So it's not gonna keep working for every single list. We need to, what if my list is smaller? Or what if my list is smaller and I have few elements? It's gonna go out of bounds then. So what I will want to do is I'm going to want to think about, okay, well, okay, so this is fine. Index is 0 to this, right? And again, like to see what happens if I do 9. It's going to be index out of bounds, error, index error. Because it's out of range, because there are 9 elements, so you can go from indexes 0 to 8. So what you see here is the 378 elements in another list here. So if we want to make this more dynamic, what we have to do is we have to basically go through and figure out what is happening each time. Each time, what am I doing to this list? So we see that we can start out with another list at 0. We can start out with some value. And isn't it true that if I look at another list like this, that if I look at this, it's basically 9 plus 29 plus 0 plus minus is minus 2 value plus 3 plus 28 plus 100 plus 200 plus 11. And all of these add to 378. So if I have some value that's called the sum value, I can say it equals all of these. But what I'm doing each time is I'm just adding. What I'm doing is I'm adding each time. The way that we can think about this is if we remember like adding, like in PEMDAS, parentheses, exponents, please excuse my dear Aunt Sally, please excuse her. So what I can say I'm doing here is this is essentially the way I can solve this is I can say, hey, I've got 9 and I've got 29. So let me add these two together and get 38. Done. Then in the next one, what I can do in the next step is say that, hey, let's focus on the next two. I have these two. So I'll move this over to the middle here. I have, these two over here, 38 and 0. Why not I just do 38 plus 0 and get 38? So, okay, now I have just 38. I've added these together. The next thing I will do is I'm going to now focus again on this 38 and this plus negative 2. So if I have 38 and I add negative 2, that's the same thing as subtracting 2. So that gives me 36. So I'm going to move 36 here. Now, sorry, I know that was a bit tricky. Now, if I add these, if I look at these, for instance, I see 36 plus 3. That's 39, so I'm going to add these next two together, 39. and so on. So I see here, like again, that I'm going to be adding 39 plus 28 together, and 39 plus 28 will be equal to 67. So what I'll do next is I'm going to then have 67 right here. And I just add the two together. Like imagine like mentally what happens in the brain when you're trying to add these together is if you can think in that way, what you'll be landing up with is you're going to see that if we can sort of take this sum apart, like if I didn't have any calculator or way to go about it, for instance, I could go from left to right in this way. If we think about it, this is sort of how we are proceeding. So this is 367 because we add those two together. And then lastly, we focus on these two, and then that will give us 400. I think I messed up somewhere. $67 plus 100. Plus minus 2. Oh, wait, this is 378, my bad. So this is 378. So this is how we can derive all of these by thinking in these terms, add these two together, add these two together next, add these two to so add these two together, get 38. Then add 38 with the next number to get this 38 again, add 38 with this -2 to get 36. Then have this 36 and add 3 to get this next number of 39. For 39 and 28, add them together to get 67. For 67 and 100, add them together to get 167. For 167 and 200, add them together to get 367. And then for 367 and 11, add them together to get 378. So what you're going to see here is that these are the values that we have, 378. So what we can do is we can almost decompose it in a way. So if we have our sum, so what we can see essentially is that we have some sum value here. The first thing that we do in this is that what is the first thing that we added? We essentially added, so we have sum value equals 0, okay? So let's pretend, and we want it ultimately, this is our goal. Our goal is to have, we'll be very, very happy. So we have a smiley face if the sum value equals this. So the sum value is the sum of all elements in another list. So what we see here is that we can do sum value equals 9, 0 plus 9. So this allows us to add. So if I show you another list again, let's just bring it down here, just so we can focus a bit more on it. So what this will allow us to do is to just do 0 and add first element to sum value. Then what we'll do is we'll do sum value equals sum value plus, and you'll see that this is sum value 0. You can actually just write it like this, add first element to sum value. So if we do this, what this is doing is it's just taking our original sum value and we're adding 9 to it. That is actually the same thing as us saying sum value plus equals 9. That just means we're adding first element of 9 to sum value. So similarly, what we can do is we can see sum value is equal to sum value plus 29. The 29 is what we added here, 9 plus 29. So please add second element of 27 to sum value. So that's the same thing as us doing sum value plus equals 29. 29, yeah, so this should be 29. So similarly, we will do sum value plus equals 0. So we add the third element of 0 to sum value. And then that's the same thing as sum value plus equals minus 2. You can just also have it here if you're comfortable. So please add the fourth element of minus 2 to some value of 3, you know, here. Please add the fifth element. So you can see here it gets very a little bit exhausting, right? Similarly, if we were to finish this up, what we would get is we would get like, so let's just finish off the 3, and we have 28, then we have 100, then we have 200, and then we have 11. So 5th, 6th, 7th, and 8th, and I'm going to add the 9th element of 11, and 200, and then 100, and then 28, and 3. So what you see here is that this is how we can go through it in a way. So this is all the numbers in our list, another list. So if we want to make this more dynamic, what we can see is that like this will change based on like if we're looking at another list or if we're looking at my list, which has different numbers in it. So to make it better, what we will see is that we can write a for loop for element in another list. Print element, for instance. What this does is it gets us 9, 29, 0, -2, 3, 28, 100, 200, and 11. And what you'll see here is that if we can somehow element goes to this whole list, and it gives us this 9, this 29, this 0, this -2, this 3, this 28, this 100, this 200, this 11. It's the same thing as us writing for I in range 0 to length of another list. You know, print I will give us all the I values 0 to 8, but to access each element, we can say element equals another list at I, and we can print out element, and it gives us the same thing. So you can do it either way, you know, with this for element and this, so you can have this, right? Like you can have the same thing, you know, I equals, and element is, so we can have a little smiley here. So you see here I equals 0, and it gives you each of these elements. So the idea is that we can keep a sum value equals 0. We're going to need it because we need sum value equals 0 to start our list with. 0 does not change the sum. In multiplication, 1 doesn't change the sum either. Like if you multiply an element by 1, it's the same element. You add 0 to anything, it's the same. So what we do for each step, we see that we just are adding each value to it. So if I could hold on to some value and in the for loop, add 9 to the list, I can do that. So I'm going to do print. Instead, I'm going to do sum value. So I'm going to have my element, and I can say my sum value plus equals element. And then I can print. Please note, we added, I can actually use the formatting, these F. Let me show you. We added element to sum value, and now our sum so far is, and I can do sum value. So I'm putting in this takes this as a variable, sum value is this variable here, and element takes this as an element. So you can see how how it does it, right? We have a little smiley here. We added 9, and now our sum so far is this. You can see that we added 9, then 29, then 0, then -2. So this is how you write a for loop to take the sum of everything. And similarly, what you see here is that you can do the same thing here, where we can have our sum value, and we can do a sum value equals sum value plus element, or you can do it this way, or we can just do sum value plus equals element. You know, appends sum value to element, and adds the element to our sum value. You can just break up a sum of a lot of numbers into like pairwise sums that you're adding. So in the end, we can also like just see if our sum value is indeed 378, which it is. So this is a really dynamic way. And using this idea, I can also figure out the sum of my list. I can just change my list here to my list. And I can get those values. Like 53 for my list, if I change it to my list and my list. In fact, because this works, what I'm going to do is I'm going to define that takes any list and sums the numbers in that list. So if I write such a code, what I will see here is that I can just take, like, let's just say I want to take this one. I can take, define a function that's called sum values list. And then it takes sample list. And what it does is it takes any list and sums the values in that list. So we have some value here. And we are going to take some sample list, which is our parameter. And because it's our parameter in this function, we can just put wherever we see list, we put sample list and sample list. And then we can return some value. And we can say print, we can have a print statement, print. Please note that the sum of all values in sample list is, and then we can print some value. And then what happens is that we can do some values as sample list, and we can call it now on another list. And then we will get you'll get the same thing to print out here. Let me actually comment that out and show you. We get like 378. I can also call it easily. It's a function. I can call it directly on my list. I can call it on anything. You know, this is 53 as we've seen. I can also just call it like on like anything I make up like as well. Like I can do 1, 3, 9, 3, 29, and I can also get like the sum here, like 42. For anything I can call it. In fact, Python has come up with the sum function. You see it's colored pink or purpley. So sum any values, like I can sum up my list and I can get like it all figured out. Like, so somebody has written out this as a function. So this is Sania's version of this list. Thank you.